Hello viewers, thanks for stopping by to watch my video. So this is a small presentation on a project demo on automatic washing machine which has been developed by our team as a part of embedded system internship at Emertxe. My name is Kesri Somashekhar Reddy. I am from Veltech University. My other teammate is Mukta Mandolkar. She is from SG Balikunde Institute of Technology. So washing machine has become an integral part of human beings. It is being used regularly by them for performing their daily chores of washing clothes. Over the course of time, washing machine has evolved. This has happened due to the rapid advancements in the embedded technology. So through this project demo, we will try to understand how we can model our own washing machine and what are the difficulties that we are going to face and how we have solved them. So the requirement for this project can be divided into two categories, the hardware and the software. The hardware include your LCD, keypad, timer, microcontrollers and interrupts. The software include your MPLAB XID and PixSimLab. So the key takeaway from this internship can be divided into three categories, that is your embedded C, PIC16F877A and the hardware. In embedded C, we have covered the basics of data structures, data types, pointers, function call and definition, macros, and header file. In PIC16.8 F778 microcontroller, we have tried to understand the number of pins, some of its functionality, about the timers and its register, interrupts and its register. In hardware, we have covered LCD display, fan, and buzzer, and how to handle them along with the microcontroller. So let's try to understand each and every component. Microcontroller. Microcontroller is a device which has its own inbuilt memory and the processor. PIC is such a microcontroller. The full form of PIC is Peripheral Interface Controller, which is developed by Microchip Technology. So because it is very easy to use, PIC16F877A is prominently being used by the beginner and the professional. Some of its properties are it is a 8-bit microcontroller, it has RISC architecture, it is a 40-pin device, it has 10-bit analog to digital converter. Keypads. So this is where the user gives input to turn on or off any particular device into the microcontroller. They can be triggered in two different ways, that is your level triggered or edge triggered. Level triggered is activated when voltage is in one high level. Edge trigger is activated when the level of the voltage is suddenly changed from one of the level to another level. So they come in two different configuration. One is sourcing for a circuit and another one is sinking circuit. Sourcing is when one is considered to be on and zero is considered to be off. And in sinking circuit, one is considered to be off and zero is considered to be on, just the opposite. So the diagram here is just a representation of the sinking circuit. The next component is CLCD. CLCD is a dot matrix liquid crystal display, as you can see on the right of the screen. So it can be operated in a 8-bit mode or a 4-bit mode. It comes in different cross section, that is a 16 cross 2 or 16 cross 4 display or 20 cross 1. So any one of the display it can come. So these are the pins that are available within the CLCD. Here RS means register select. So if you are giving 1 to it, then we can input the data or take out the data. And if you are giving 0, then we are providing instruction to the CLCD. So these instructions can be like in order to clear the screen or in order to clear the screen and turn on the cursor. So next pin is RE, that is read enable. This pin, if it is not 1, then RS and RW value will never be considered. So this value needs to be 1 in order for the consideration of RS and RW value. So in read write, the next pin is RW. So read write. If 0 is given to this pin, then it means write. And if 1 is given, then it means read. So the rest remaining pins D0 to D7 is data line. So if we want to put the cursor at any particular address in the CLCD, then we need to provide the address, that is the row and the corresponding column. So addressing in a 16 cross 4 LCD display is done through rows and column addresses. Timer. Timer is nothing but simply a binary counter that can be configured to count clock pulses. So once it reaches the maximum value, it will roll back to 0, setting up an overflow flag and generate the interrupt if enabled. So PIC1685577A microcontroller has three timers which are independent of each other. They can be used as timer, counter or PWM generators. So they are timer 0 which is an 8-bit timer, timer 1 16-bit timer, timer 2 8-bit timer. Some of the basic terms associated with timer. Prescaler, part of a microcontroller that divides the oscillator before it will reach the logic. Before it will reach the logic. FOSC, the frequency of crystal oscillator. So this is the frequency of the crystal oscillator which will vary with board to board, which will vary with microcontroller to microcontroller. For PIC16F877A microcontroller, it is 20 megahertz. As the timer increments and when it reaches its maximum value of 255 for an 8-bit mode or 65,535 for 16-bit timer, it will trigger an interrupt and initialize itself to 0 back again. This is called an timer interrupt. Interrupt Interrupt is a communication process which causes the processor to stop its current task and handle the interrupting sources. The sources can be external or internal. So some of the terms associated with interrupts are interrupt vector table and interrupt service routine. Interrupt vector table is nothing but a data structure that associates a list of interrupt handler with a list of interrupt requests. Interrupt service routine is a software routine that hardware invokes in response to an interrupt. So ISR examines an interrupt, determines how to handle it, executes the handling, and then returns a logical interrupt value. So PIC has only interrupt service routine. So these are the software components that are required for the project. The first one is MPLAB XID. MPLAB XID is a free integrated toolset for the development of embedded application on microchip PIC and DSPIC microcontroller. It is an integrated development environment. PICSIM Lab. PICSIM Lab is a real-time emulator of development boards with integrated MPLAB AVR GDB debugger. PiximLab supports some Pixim microcontroller as well as some simple ASIM AVR microcontrollers like Arduino. So this is a snapshot of the hardware that we are going to use. The microcontroller is PIC16F877A, the board is PIC Genius, and the software that is being used on which we are going to use the hardware is PiximLab. So this is the software where we are going to write the code and execute it. So now let's go to the project demo. So this is the project demo. As you can see here, the starting screen shows press key 5 to power on the washing machine. This is the initial screen that the user can see, and it is prompting the user to press switch number 5 to start the washing machine. So see, it is showing powering on washing machine, an imaginary company, and then it's going to the washing programs. So it is moving from the powering on to powering on display and then to the washing programs display. So the washing programs shows around 12 option, out of which user can choose any one of the option. And for per screen, we can see only first three options. So in order to scroll between different options, we are going to press switch number 4. And if we want to select any one of the washing program, then we can do a long press on it. So for the purpose of demo, we will choose best sheets and we will do a long press. As you can see, as soon as I am doing a long press, that is continuously pressing the key at one point, then the particular program is selected and it will move on to the next screen, that is the water level. So water level also offers the around 5 choices out of which user can choose. So the water level and the washing program determines the overall time required for that particular washing program. So for the purpose of demo, let's choose the option high. So the next screen that is showing is start stop screen. Now if you press the stop screen, then it will again go back to the washing program display. And if you press start, then it will go to the next screen. So let's go to the next screen. As you can see, it was showing the program and the time estimated for the completion. Now the timer is being run and the fan is on. So the washing machine is turned on. Now if we press switch number 6, it will be paused. So the fan will be turned off and the timer will be also paused. Now but if I again press switch number 5, it will continue the washing program. Here, if you see, there is a function that is being displayed. The function actually are there are three functions that are present in the washing machine. First is wash, then spin, and then rinse. The wash occupies 42%, the rinse occupies 21%, and spin occupies rest percentage of the total time. So if I again press switch number 5, then the washing machine will be resumed. But if the user opens the door by mistakenly, then it will give a warning to the user that the door is open. Please close the door with a buzzer on. As you can see, the function is currently spin. See, as soon as the timer becomes 0, the washing program gives a message to the user that the washing is completed and remove your clothes. So this message will be displayed for around 5 seconds and the buzzer will be also turned down during this process. So once this is done, then again the washing machine will go back to the washing program display state. So again we can, if we want, we can select any one of the washing program. So this is the overall project. Now let's see the code. So this is the code which helped in execution of the which helped in execution for the project. So this is the main C file and the rest are all used to contribute to this main.c file. So the rest are header files as well as C files which are included in order to access peripherals, be it timers, CLCD or digital keypad. So as you can see, these are the global variables which help in determining the current state of the washing program. So the next is the washing program array, which contain 11 different washing programs that a user can select from. The next one is water level, which is the third screen. So water level offers overall 5 choices, out of which the user can select any one of the choices. The total time varies depending upon the washing program selected as well as the water level selected. This is the initial configuration. That is, we are initializing the whole system by configuring the all the components that is being used to its initial state, to its default state. Then this is the main part of the program where the state of the washing machine is changed from one state where the state of the washing machine is changed. That is being from washing program to start stop program. So this function is used for clearing the screen on LCD, CLCD. This is the function that is displayed during the power on. There were two messages that came during the power on, that is powering on washing machine and the imaginary company. The next is start stop display. So this function is called when the user selects the washing program display as well as the water level. Then he is prompted with the message in order to start the program or stop the program. Now if he presses if he presses switch number 6, then the program will be stopped and move back to the washing program display. That is, it will return washing program display state to the operation mode. So the next function is water level display. So this is just a function which is used to display the water levels on the screen. That is auto, low, medium, high, very high. And we can easily scroll between each of them using switch number 4. So once there is a long press, then it will go from water level display to the start stop program display. So this function is washing program display, and this function is used to show the washing programs that is present in our washing machine project. So there are 12 different options out of which the users can select any one of the option. The other for the another next function is set time for the program. So this function sets the time that is according to the washing program that is been selected and the water level that is selected. For example, if the user selected daily program and now we go to the switch case inside the case 0. So this decides which of the water level the user has selected and what the time needs to be set. So for example, if the user has selected low, so low is case 1. Now the second will be set to 33 and minute will be set to 0. So like that the time is set for each individual washing program depending upon the water level. The next function is door open. So this door open will check if the user opens the door in between the washing program run. So if the door is open, then it will prompt a warning message that door is open, please close the door. So the last and the main part of the program, that is the core and the heart, is the run program. So this program will start the run of the program and will display the seconds and the minutes that is left and the current seconds and minutes that is going on. So this function will display the time that is currently going on and the total time that is required to complete the program. Here we have seen that the wash cycle is set for 42% of the 46% of the total time, and the rinse cycle is kept for 12%, and the remaining time is kept for spin time. So here we are turning on the timer and the fan in order to run the program. So that's how our whole washing machine setup is working. So this is a simplified block diagram explaining how the whole process is going on. So in conclusion, we can say washing program has placed a very important role in the modern society. So in this project, we have tried to model a washing machine by going through embedded development cycle. We have understood the requirement of the customer and have tried to add some of our own feature in order to improve the experience. So this, while implementing, we divided each function into modular program and tried to combine the whole. This made the whole process of development easier and we are able to detect any anomalies easily. Thank you for watching my video.